What if every decision you never made, every path you never took, exists somewhere right now? Welcome to the multiverse, a radical idea at the frontier of modern physics. In this video, we'll unpack elite-level scientific theories, explore fine-tuning Boltzmann brains, and whether this infinite universe idea is actually science or just sci-fi. Chapter 1. What is the multiverse, really? The multiverse isn't just science fiction anymore, it's one of the most talked about and controversial ideas in theoretical physics. But here's what many people get wrong. The multiverse isn't one theory, it's a collection of different concepts, each with its own scientific origin. Let's break them down. Quantum multiverse, based on quantum mechanics. Every time a particle makes a choice, say, to spin left or right, it creates two realities. One where it spins left, another where it spins right. This is also known as the many worlds interpretation. In this model, every possible outcome of every event happens in its own branch of the universe. Cosmic inflation multiverse originates from the theory of eternal inflation. Our universe may be just one of countless bubbles forming in a rapidly expanding cosmic foam. Each bubble has its own laws of physics. Think of it like champagne. We're just one bubble in an infinite bottle. String theory landscape. String theory predicts about 10 to the power of 500 possible vacuum states each, with its own physical laws. That's a 1 followed by 500 zeros. You could spend 1 trillion years exploring and you'd barely scratch the surface. Sounds impressive, right? But here's the twist, not a single one of these multiverse theories has been proven, not one. Chapter 2. The fine-tuning problem. Our universe seems absurdly fine-tuned for life. A tiny change in the strength of gravity, no galaxies. A small tweak in the charge of the electron, no atoms. Even a 1 in 10 to the 60 variation in the early expansion rate of the universe, and everything collapses or expands too fast for stars to form. This freakish precision begs the question, why? There are only two answers. It's designed that way. Or we're just in one of the lucky universes that happens to support life. That's where the multiverse becomes convenient. If there are an infinite number of universes with all possible variations, then some will look exactly like ours purely by chance. And here's where things get slippery. Instead of proving why constants have the values they do, multiverse proponents say, of course we're in a universe that supports life, where else could we be? It's called the anthropic principle, and it's elegant, but also deeply unsatisfying. Chapter 3. Boltzmann Brains and the Logic Trap. Here's where things get weird. In the 19th century, physicist Ludwig Boltzmann imagined that in an infinite amount of time, random fluctuations in chaos could create order, maybe even a whole universe, or a fully formed brain. Now let's say you believe in the multiverse. If universes pop into existence randomly, then it should be far more likely to get a small, simple thing like a brain that randomly forms with false memories than an entire universe. These are called Boltzmann brains. Statistically, Boltzmann brains should vastly outnumber real people like you. That means, under the multiverse, it's more likely that you're a floating brain with fake memories than a real human in a real universe. That's not just disturbing, it's self-defeating. Chapter 4. Why can't we observe it? Science depends on testing ideas, running experiments, making predictions. But here's the core issue with the multiverse. You can't observe other universes. Not directly, not indirectly. Ever. Think about it. By definition, if another universe is truly separate from ours, different space, different time, it can't interact with us. That means no light can travel from there to here, no signal, no gravity, no detection, no way to confirm it exists. Multiverse believers often compare this to black holes. We can't see inside a black hole either, but we believe in them because we see the effects. That's not the same. We can observe the gravitational pull of a black hole. We can see stars orbiting nothing. We can measure radiation. But the multiverse, no such evidence. Chapter 5. The measure problem. Let's say there are infinite universes. Now try to ask, what's the chance that a random observer sees a universe like ours? Seems simple. But in an infinite set, you can't define probabilities without a rule called a measure. And here's where everything breaks. Depending on the measure you pick, you get wildly different answers. One method might say we should be surrounded by chaos. Another says we should live forever. Another says our universe is nearly impossible. That's the measure problem, and nobody has solved it. It's like trying to define average wealth in a city where some people have $0 and others have infinite dollars. The math just breaks down. Some physicists try to fix this with clever tricks, introducing cutoffs, weighting different regions, inventing mathematical hacks. But none of it is natural, it's all arbitrary, and that destroys predictive power. If a theory can explain everything, it explains nothing. Chapter 6. So why believe it? Why then do elite physicists still push for the multiverse? 3 main reasons string theory needs it. String theory. The leading candidate for a theory of everything doesn't give one answer for the laws of physics. It gives 10 to the power of 500 possible ones. Each corresponds to a different universe. So if string theory is correct, and that's a big if, then the multiverse follows naturally. But here's the problem. String theory itself has no experimental support, not one confirmed prediction, not one falsifiable claim. It's elegant, yes, but not verified. Eternal inflation implies it. Inflation, the rapid expansion of space right after the Big Bang, is well supported. But if inflation never fully ends, it creates new regions of space endlessly. That's the inflationary multiverse. Still, we only observe our own universe. Eternal inflation is a projection, a mathematical extension, not a measured fact. Avoiding design. Let's be blunt, for many scientists, the multiverse is attractive because it avoids any idea of intelligent design. If there's only one universe and it looks fine-tuned, that raises uncomfortable philosophical questions. But if there are infinite universes, no problem. Ours is just one that got lucky. That's not a scientific argument, it's a philosophical preference. Chapter 7. The Architects of the Multiverse. You've heard of Einstein, Hawking, and Feynman. But the real muscle behind the multiverse idea? These are the lesser-known scientists who shaped the idea. Linde. Linde proposed that inflation never truly ends. Instead, it creates a multiverse of bubble universes. His 1986 model is still central to multiverse thinking. Linde believes our universe is just one island in an endless cosmic sea. But here's the twist. Even Linde admits we may never prove it. The multiverse is a theory of eternal hope. You can explain anything, but you can't verify anything. Max Tegmark. Tegmark created the 4 levels of multiverse of regions beyond our cosmic horizon, quantum many-worlds, universes with different physical constants, mathematical universes where every logical possibility exists. Yes, including a universe where you're a pink dinosaur hosting a podcast. Tegmark's theory is bold, but purely mathematical. It's entirely untestable. Carroll defends the many worlds interpretation of quantum mechanics. According to him, the universe splits every time a particle interacts. There's a version of you watching this video. Another is brushing your teeth, another eating a taco. Carroll says we shouldn't demand proof in the traditional sense. If the math works, it's real. But that's not science, that's belief in equations. Susskind helped connect string theory's massive landscape of possible laws to the multiverse. He argues that the multiverse is the only way to explain fine-tuning without invoking God. His warning: if you don't accept the multiverse, you must believe in a miracle. But remember, lack of a better explanation doesn't make something true. Chapter 8. Is this even science? Let's return to first principles. Science is not about what's mathematically elegant or what's philosophically satisfying. It's about testing ideas against the real world. The multiverse makes no unique, testable predictions. It cannot be verified, and its strongest support comes from untested theories like string theory and eternal inflation. That doesn't mean it's wrong, but it means it's not science in the traditional sense. If we accept it as scientific, we risk opening the door to anything: simulation theory, alien dream worlds, gods. In a desperate attempt to explain everything, the multiverse may explain nothing. So, is the multiverse real? Here's the bottom line: the multiverse is an elegant idea, not an established fact. It explains fine-tuning, but does so by invoking infinite unobservable realities. It relies on untested theories, suffers from deep logical problems, and is arguably non-falsifiable. Its most devoted supporters, Linde, Tegmark, Carroll, Susskind, are brilliant minds but also true believers in a theory that goes far beyond evidence. The multiverse may one day become part of accepted science, or it may fade like ether theory and phlogiston. But today, it's not a proven reality. It's not even a theory in the proper scientific sense. It's a reflection of our desire to explain the unexplainable without invoking design, without admitting mystery. And that's not science, that's philosophy, wrapped in cosmic glitter.